Assalamualaikum and good day everyone. Today, we will present our project which is the 20 oscillator. So, I will explain the introduction. The 20 oscillator is a type of RC feedback oscillator. It is widely used to generate sine wave, especially in audio frequency application such as tune generators and signal testing equipment. It is called 20 because it uses two shaped RC filter networks, as one is a low pass filter and the other is high pass filter. When combined, they form a band stop filter that only allows a specific frequency to pass through with positive feedback. This selected frequency becomes the oscillator's output frequency. The oscillator uses an amplifier, typically an op-amp, to provide the necessary gain to sustain the oscillation. Now, I will explain the circuit diagram of the 20 oscillator that you can see on the screen. This oscillator is based on a negative feedback amplifier and a special RC network that acts as a frequency selective feedback path. The goal is to produce a pure sinusoidal waveform at a single frequency. Let's break down the components one by one. Okay, at the left side of the circuit, we can see the 20 network. It consists of two shared RC branches. The upper T network is made of two resistors, R, and one capacitor, 2C, in the middle. The lower T network is made of two capacitors, C, and one resistor, R/2, in the center. These two networks are connected in parallel, forming a band stop filter which blocks a specific frequency from passing through. But when using feedback, it allows the frequency to oscillate by feeding it back with the correct phase shift. Next, on the right side of the diagram, we have an operational amplifier labeled as AV. This op-amp provides the necessary gain to compensate for losses in the passive network. It ensures the signal grows during startup and stabilizes during continuous oscillation. The positive feedback is applied through the 20 network, and negative feedback is set by the resistor R1 and R2, which control the gain of the amplifier. Finally, the output is taken from the amplifier and provide a clean sine wave labeled as Vout. This sine wave has a frequency determined by the value of the resistor and capacitors in the 20 network.
We now move into the startup condition. To start making a sine wave, two things must happen. The loop gain, which is amplified gain times feedback, must be slightly more than 1. The phase shift around the whole loop must be 0 degrees or 360 degrees. The 20 part doesn't change the phase at the right frequency, so the amplifier also should not add any phase shift. This helps the circuit take small noises and turn them into a full sine wave. Next one, we move to sustain. We're now getting moved to sustain oscillation. Once the sine wave starts, we want it to stay steady. For that, we need, the first one is loop gain must be 1, and the second was phase shift must be in 0 degree. This keeps the wave from getting bigger or smaller, just stays smooth and steady.
So we're gonna start with the important formula. First, we got low pass network and a high pass network, which we combined and it became a T-twin oscillator. First, for the low pass RCR network, we can see the formula started with FC equal to 1 over 2 pi, set 1 over C plus 1 over C over 2C multiplied by R square. Then, it got combined with a high pass CRC network, which we can formularize by using FC equal to 1 over 2 pi, set 1 over C square multiplied by R over 2 multiplied by R plus R.
So, low pass will be plus with the high pass RCR network. Like we could see at the feature, FC equals to 1 over 2 pi set 1 over C plus 1 over C over 2C multiplied by R square. And firstly, we will solve 1 over C plus 1 over C equals to 2 over C. And then FC equals to 1 over 2 pi set 2 over C over 2C multiply R square. And then we multiply it and it will become 1 over 2 pi set 1 over C square multiply R square. We dissolve it and it will become 1 over 2 pi CR.
The twin T oscillator is a type of RC oscillator that produce a clean sine wave. It works using two T-shaped RC networks, hence the name T-twin. These networks are placed in the feedback loop of an inverting amplifier, allowing the circuit to oscillate at a fixed frequency. One of its key applications is in notch filtering. It can effectively eliminate specific unwanted frequencies such as the 50 or 60 Hz hum from power lines. This is especially helpful in biomedical signal processing where clarity and accuracy are critical. For example, in ECG or EEG system. Between the 1960s and 1980s, 20 oscillators were also central to analog synthesizers like the famous modular. Their low distortion made them ideal for generating clean audio signals. They are also used in musical instruments to produce low frequency tones and dampened oscillation, which are great for simulating percussion sound. Even though digital solutions have taken over many years, 20 oscillators are still widely used in low-frequency analog applications like seismic sensors and LFOs because of their simplicity, stability, and low cost. In summary, the 20 oscillator is more than just a sine wave generator. Its ability to filter, synthesize, and support low-frequency analog system make it a versatile tool in both engineering and music.
So to wrap it up, the 20 oscillator makes clean sine waves using only resistors and capacitors. It starts working when the gain is a bit more than 1 and phase shift 0. It keeps working steadily when the gain is exactly 1. It's simple, stable, and great for low frequency electronics.